Metal casting is all about dealing with molten metal. Here we pour molten metal in a mold cavity and wait for the metal to solidify in order to get the final casting. So we should have a very fair understanding of the physics behind the solidification of metals and alloys. So if we analyze in a temperature versus time plot, we will see that when we pour the molten metal, the temperature gradually starts to decrease over time due to the heat loss from the surroundings. Heat loss to the surroundings. Next, when the material's freezing point temperature will be reached, the phase change will start. And we know that during the phase change, the temperature always remains constant. This is because the molecules starts to slow down and rearrange themselves in the solid phase. Thus, this energy is used in molecular rearrangement without any change in temperature. So, from the pouring temperature till this point where the freezing stops is the total time required for solidification. Finally, as we cool the metal further, it gradually comes further down to the room temperature. Now, let me show you a real example of this by considering the solidification pattern of copper metal. Copper usually melts at around 1085 degrees centigrade. So let us suppose we have heated it to a temperature of 1300 degrees centigrade. So this is the pouring temperature. Now the curve will decrease gradually till it reaches 1085 degrees centigrade. Then it will remain in this temperature for some time during the phase change. Now we have solid copper. Further cooling will bring down the temperature to the room temperature. Now let us see what happens in the microstructure level. Suppose this is the mold cavity carrying the liquid metal. The liquid metal has a uniform temperature all throughout. Now the mold surfaces are at a much lower temperature as compared to the molten metal. So due to the temperature difference between the mold surface and the liquid metal in contact, the heat transfer takes place rapidly and solidification starts from the interface between the liquid metal and the mold surface. Small crystals starts to develop near the wall. As time proceeds, these crystals starts to increase in number. These crystals are these crystals are long in shape and their axis is perpendicular to the mold surface. Since in the left hand side the crystals have obstacles due to the solid mold surface, they can elongate only toward the free end. And while doing this, the structure becomes stretched. Okay. Now the same phenomenon will take place from all the three surfaces, and finally we will see millions of crystals solidifying into the solid state. In case of alloy, everything is same except the middle stage of this plot. Here the temperature will not be constant as we have seen in the previous case, because an alloy has more than one metal, and hence each of the constituting metal will freeze at their respective temperature. For example, brass is an alloy of copper and zinc. Both these metals freezes at different temperature. So naturally we will have a range of temperature for freezing of brass. Since the solidification is not uniform throughout the entire material, various nucleation sites are formed where the solidification starts. Okay, as these solidification points grow, they proceed like tree-like structure called dendrites. Let us now see this phenomenon in a micro level. First, small nuclei of solid starts to form in the liquid pool. Next, the dendrites starts to originate from this nucleation sites, from this nucleus. Then in the step 3, the dendrites starts to grow in size, and after some time the space between the dendrites starts to decrease, and finally the grain boundaries meet, and this completes the solidification of alloys. Okay, so this was all about the solidification pattern of metals and alloys. For more such videos, keep supporting Meg Vidya.